Jonathan, I haven't met you before. Is this your first class here?
No, I've been attending the sessions, but
Okay, yeah. Maybe I did not notice you. And this session alternates between me and Enrique taking it. And our vision has always been this to be like more like office hours where we can bring in people can bring in their questions and we can look at it if they have any more like a hands-on AI. But usually we don't have a lot of that. So we kind of just go through topics which we think is helpful for people on campus to get hands-on with LLM, especially in the research. Uh, yeah, like Jake or Jonathan, do you have like any particular issues you're dealing with from either from what we
no,
have
nothing
in?
really today. So just here to
Yeah,
see
no,
what
no
other
issue.
people are doing.
Mithun, I run into a lot of issues with installing the various packages and getting like dependency resolver issues. Are there any sort of hacks to get around that?
So my first question is, where are you running this? Is it on your laptop?
Uh, yeah, although yes, on my laptop, but using different resources. Like I saw the notebook that you put up for today's session. And so I tried to install, and I opened it in the discovery environment.
Cybers, okay.
Yeah. And when I try to install LangChain, for instance, it gives me pips dependency resolver, blah, 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 lots of red text. And yeah.
Interesting. So, are you using some sort of a virtual environment like Conda or something?
No.
Okay, so, and what operating system do you have?
Windows.
Okay, so especially in Windows, so it is important that we use, I don't know if, like, let me share my screen and introduce you to Conda, because I haven't touched Windows in 20 years. Nevertheless, I'm just in sure, can you see the screen which has Conda?
Yeah.
Okay, so Conda is an open source package, and the whole idea is sandboxing. Okay, it has Windows too, cool. So the idea is that we sandbox these packages just for that particular project. And in fact, people do it like to November 4/15, it's my Conda environment, and everything I do today will be only inside that virtual environment. Right, so that way you don't touch the operating system, because once you touch the underlying operating system, it already would have come with a bunch of Python versions that it's familiar with. And then it's going to start complaining that, oh no, the one you're downloading doesn't match with my Python version, which was probably 2 years ago, and it's hard coded and they cannot change. So we always suggest people work on Anaconda or Conda. Another option you can look at is VENV, virtual environment. But personally, I like Conda better. So what I do personally is, let's say, let me pull up one of my Conda environments. So this is another project I'm working on. So every time it's called QNLP, which is stands for Quantum NLP. So every time I start the work, today, let's say I'm working on QNLP, the first thing I do is like I start a fresh session on a terminal, and I I might not remember what the corresponding Conda environment I had created was. So I list all my environment and it reminds me, oh yeah, I had this. Oh yeah, I had this for this project. I had that for that project. So that kind of ensures that every install I do relation to the project. So the way we kind of create this conda create minus minus name uh, test and Python equals to 3 dot, just put 3. So we can choose which Python version we want. And usually when you're installing, like with a pip install, they kind of expect the latest Python version. So it's almost like we are creating an operating system, but with our own packages installed. So now it'll ask me like, hey, do you want to install Python, pip, etc.? It shows me the Python it'll be doing is the latest 3.13, and by default, pip is also 13. So these two lines alone kind of does a lot of magic because it's kind of ensured that it's everything is latest. They have backward compatibility. While if you do that on a command line on Windows, it probably is going to what we call a, let me see, yeah, the base. So base, like, I don't know if you can see this, the base is what the operating system's environment is, and you never want to install anything on it.
Okay.
So yeah, I would say read on Conda. That's like amazing everywhere. And in fact, most of my work in cybers also is always segregated by Conda environments. Even HPC, it's important that you have a Conda environment because you don't want to touch the underlying operating system or whatever they are providing. Sandboxing and modularizing, that's all it is basically.
Okay, cool. Thank you.
Nice. Okay, anything else I can help you with in your implementation? No? Okay, so I was thinking today, since you already saw my Python file, the notebook I had uploaded, and Jonathan, I don't know if you're familiar with our workspace. It's called UA Data Lab in GitHub, AI Makerspace. It should be there in somewhere in one of our web pages or something. So what we have done is usually like every session has a corresponding file. So I was going to look at like this was the last time. Okay, let me show you the calendar because this is how we have been doing it. Like Enrique started with PyTorch and distributed GPU. He showed you how to fine tune an H5. I brought in a little Olama in between, and he has been showing more of information extraction and parameter efficient tuning. His is a little bit more at the abstract level. Mine is a little more hands-on and current. How do you want to do it today and now? So in my last class, I had introduced what Cyverse is, like, which is similar to a high-performance cluster, but a much more user-friendly environment. And AI Verde is our, gargantuan, gargantuan. I don't know how the Americans pronounce it, but the huge collection of models which we are providing for free for everybody inside campus. And I had talked a little bit about prompt engineering. And in fact, that is where I wanted to start. Let's see. Yeah, so I don't know if Jake, if you remember this, like we had done this whole chatur chains, which is what we had created for this AI Verde. And the idea is like, okay, sure, when we saw Olama, we saw that we can create a prompt and ask questions to Olama, and it kind of replies with whatever so google.com and on Olama. It replies with a bunch of answers. But as a researcher, like this, right? This is the kind of command line we had shown before, like, hey, here are the questions, etc. But as a researcher, this is like child's play because you don't want to rely on the data that Olama has learned. You would rather fine tune it or train it on your own data. So which is why we have been introducing this whole concept called RAG, and RAG stands for Retrieval-Augmented Generation. And the whole idea is normally, before RAG came into existence, we were taking like this large language model and trying to fine tune it, which means let's take this huge resource of a large language model and rerun this, except this time it'll be running on my particular data. Now that suddenly became a huge mess, especially when people did not have access to that amount of resources. Like, GPTs and llamas have 7 billion parameters or weights, which is not something you can easily load in like one of your HPC machines and do a fine tuning. So which is why people invented RAG. I'm kind of doing a review of what we have done so far. So RAG is more of this idea that, okay, sure, here is an LLM, which is kind of has seen everything under the sun, maybe like most of the internet. But our goal now is to make it focus on just the little topic that I am interested in, which is what we call the specific knowledge base. You see, okay. let's say these are like, communication related experiments you have performed, and you don't want it to answer from its own knowledge base. You want it to use the skills it learned from the knowledge base, but not the knowledge per se. So people thought of this idea that, okay, hey, what if we just simply retrieve a bunch of relevant documents? And what we're doing is we are kind of focusing, making the LLM to look only on this within this deadline or the boundary, so that it is not distracted by the huge data it has. So that is what we have been seeing in our previous classes, which is we had seen that if you had Chatur, we can install what we call chains, which is kind of built on LangChain. And like this one purely was LLM.invoke, nothing different than calling an Olama, because it's all we do is specify the model and we ask it compose a haiku about the beauty of Tucson. But that is like one of the very basic methodologies. Let's see, in session 5, there must be one more. Session 5. Yeah, okay, I think I had also shown you this, where you can do a little bit of prompt engineering to make it kind of look like a pseudo RAG. First one was what I call the RAG-less prompt, which is just saying, hey, here is your teaching assistance. You always have to answer with markdown, else you'll be penalized. And we are asking it the same concept, like maybe I think the question was, what are the digits of pi or something? But then that's boring to us because it's answering from its own knowledge base. I think I showed this last time, where it's a neat trick. You are sending out your entire data within the prompt and you're saying, hey, you are a teaching assistant, you're having a conversation with a student, and the student's questions and information will be only from the reference text, which is between / reference open and close. And we say when you always answer, you should answer from it. I think that's somewhere there. Anyway, so the point is we are passing the reference text as it is to the machine or the LLM. For example, what I did in this particular case was I took the research paper I wrote on AI Verde, and I gave it as my kind of the retrieval-augmented generation input. And I asked the question, can you write a FAQ? Now answer this question, write a frequently answered question document for Verde. And it came up with this, which is what is AI Verde? Who can use AI Verde? Blah, blah, blah. Now, I think we saw this before. I'm pretty sure we did. Now, having said that, you as a researcher, if I tell you this idea that, hey, just given only an Olama, and you can create a RAG prompt and you can inject all the data you want in here, will it work for you and your use case? And when I say your use case, I'm assuming you have your own set of data from some experiments you have conducted. Can you or can you not pass it through the RAG? Why and why not? Through the RAG prompt, sorry, it should be specific prompt.
Are you asking us whether we can do this?
Yeah, so I showed you this methodology, right? Say I gave it the entire research paper and I'm asking it a question, and it did a pretty good job. So why is this let me put it this way. Why is this a bad idea if we want to work on research related data?
It would be bad if we have to, like, every time we want to ask a question, we have to feed it all of the information. It has to process the information to answer one question. Is that part of what you're getting at?
Sure.
Yeah.
Anything else?
It would be nice to update the information that it's working on sort of on the fly. If a new paper gets published, you'd want to integrate that, maybe without having to run the whole thing again. I'm not sure.
Right. Yeah, no, that's perfect. That's exactly what I was, a couple of things, including that is what I was looking for. But another major issue is all of these models, like despite their big names and 7 billion, all of them have an input limit, which is there is only so many tokens you can provide it. This is one research paper. We had recently created, I think, 50,000 research papers indexed for a professor in the ECE department. And imagine like pasting 50,000 the content of 50,000 research paper on a prompt. I mean, the manual labor of doing it itself is huge, but these machines will immediately throw you out saying, oh no, you are only allowed like your maximum token size is this, right? And then everything else you guys said, which is like the implementation overhead, we don't want to keep pasting this again and again. So which is why this whole idea of RAG came up, which is let's separate out the knowledge base from the question that you ask the LLM itself. So in fact, what we will be asking the LLM is pretty much similar to this RAG prompt. We'll say, hey, you are a teaching assistant or whatever you want to type up, and you're say, answer from this reference text. And the only difference is we are not going to pass the reference text from here, but that is going to come from a very nicely indexed data set. It's called dense passage retrieval. There are a bunch of, it's like retrieval. If you ask Google, give me the top 10 documents on American football, it'll give you top 10 pages. So this guy, the smart retriever, he modifies his question and says that, hey, you have to now answer this particular question, which is write an FAQ for Verde using this attached database. So the advantage of that is these are all separate the same modularity concept. This database can be independently updated as and when we wanted, like offline. It has got nothing to do with the question you're asking. So maybe like Jake said, tomorrow another new set of papers come in and we want to index these papers. It can be done offline and then provided as an input to LLM. Right? So that is why we have this whole idea of RAG coming in. Now, I'll just show you the code from our Verde itself. So let's see. So in Verde, if you look at it, like this is one of the examples which we had seen, and we provide a vector DB path, right? It's testing data research paper. And when we scroll down, we can see that we will be passing that as like this. We'll see this today, the dense passage retriever, etc. We are passing that path as an input, right? So this path is passed as an input first to the retriever, which is basically an information retrieval module like a Google search. And we ask it, give me the top 10 documents on pine trees non-native to Arizona, right? And then it gives me the top 10 documents. Now what I do is I take these top 10 documents, give that as an input to my original query, and ask this question, how can you treat wood rot on lemon trees? Right? And this guy will see today that we can internally, while we invoke it, we are going to pass this retrieve documents alone. So remember, now the machine has to only look at these 10 documents, the LLM. So we are already making it focus its attention on these 10 documents, and the retrieval part is done by somebody else. And of course, you can use various methodologies for retrieval. We'll talk about that in a second. So this is how we have been doing this inside like Cyverse and inside our RAG, the AI Verde thing. Otherwise, like you said, it's just a matter of time before, these models are, loading a huge amount of hardware from our resources. And imagine then feeding a bunch of text every single time. Huge overhead, not scalable. Now, what is my question here? Okay, yeah, so let's start into how we can do like a RAG on your own end. So RAG is, like I said, on one side you can sure try it on Cyverse. I would rather try it on your local machine first as a Jupyter notebook, because I want to show you, like last time in the last class, Enrique was showing quantization and stuff. So it is doable on your local machine. Let's see. I mean, the best way to find out is run it, and let's see if it crashes. So that is why I wanted to look at like this our class today. Like session 6 is RAG, Chroma, Langsmith, etc. This is my Chrome. It doesn't open on Chrome. 1 second. So let's see. Update Safari. Okay, can't find Safari. Great. It doesn't matter. I'm just going to start it again. So what I'm doing here is I just started a Jupyter notebook. Are you familiar with how to do that locally? Like, are you using Jupyter locally by any chance?
I have a little bit before. Yeah.
Yeah, so I can show you how that is also done.
Yeah, I've been switching to using the notebook.
Yeah, all you have to do is pip install Jupyter and Jupyter Lab build. And once you call a Jupyter Lab, it will kind of give you a, oh, where am I? PWD. Let's see, Jupyter, pip install Jupyter. Oops, shit, this folder. Okay, Jupyter, and then you have to do like again, I'm like the complete command line person. I'm pretty sure there's like a nice cleaner version of it. Doing it, how to install Jupyter, install. Huh, apparently not. They're also doing Jupyter Lab and Jupyter Notebook. Cool. So this is what Jupyter Lab build. What did it give me right now? Oh, all right, perfect. So it gave me a Jupyter Lab, and it usually like opens in the same folder where you started it. And I have this file here, which is what I was showing you earlier, which is what I have already uploaded to this, which will work on your end, of course. So let's go step by step and see how we do this. So let's, if you want to work with me at the same time, we can do it together. So let's start a new Jupyter page. Just I'm very curious, like Jupyter, you can actually do Conda also. I want to see if it can pick any of my Conda environments. Okay, it does. Okay, so I can maybe create a new one. So let's see. Conda create minus name Python equals to minus name equals November 15, Python equals 3, execute. Yeah, might be a mess doing it on the fly. Yeah, I have to put a minus y on the library. Let's see. Don't dash. Yes, cool. Minus y is default for it. Just don't ask me, just install it anyway. And you can activate this environment on the activate. And if you're not familiar, this is how you do command line commands, like what do you call it? In Linux or Mac, it is the operating system commands. What is this called? Activate. Huh? Whatever. Okay. So that is how it should technically work. I don't know how to do it from a Jupyter notebook, but I'll just keep going. So I have already provided a bunch of things we need to install here. Let me just start the installation and then I'll explain to you what it does. So this is, if you go here, command enter. Okay. So I want to introduce you to LangChain. LangChain is kind of at this point the one-stop shop for anything AI related. And it's literally a chain. And what do I mean by chain? So LangChain is basically, you go here and it's a framework for developing application. And the idea is it can chain one thing after the other for you. So for example, it can change like, okay, if you have a land chain, you can pick what kind of, it's pretty much like your AI, the RAG pipeline we had seen earlier. And so it's pretty much that you can just get all like a module by module in LangSmith, and which is the first thing we are installing, LangChain. And LangSmith is like a blacksmith inside LangChain who can give you more details. And I'll show you that in a second. So where are we? What else is there? So there, okay, Chroma. Chroma, so is basically, if you go here, the specific knowledge base. So these days, there is this whole idea that, like I said, it's called Retrieval-Augmented Generation. And it comes from this concept called dense passage retrieval. So before this happened, I think this paper came out in 2020. The dense passage retrieval is 10th April 2020. Until then, Google was using some traditional techniques called TF-IDF and BM25. And what that means is, if you ask a query, all it is going to see is the angle made by your query is how close it to the angle made by these thousands of documents. But that has its own restrictions because if you have tens and millions of documents, you have to go through each document and find how close your angle is. So which is why this whole idea of dense passage retrieval came up, where they kind of do this at a different plane, which is the embedding space. I mean, you don't need to know all this. I'm just giving you extra information. But the idea is when you slowly start studying on everything about LangChain. So let's look at the tutorial from LangChain on build RAG-based app. And like I always say, my goal is not to give you a fish, but more to like teach you how to fish. And honestly, that's all what they teach us in computer science for like 10 years of grad school, which is the shortest, it's called RTFM. Do you know what that is? Does anyone know what that means?
No.
So that is like our Bible statement kind of thing. RT at FM. So let me at least type it out here. I can't find the chat window. RTFM is read the fucking manual. So any question you ask your boss in computer science, anybody, they will send you back to this, like, okay, just go read the documentation. And in fact, that's all that is there in computer science. You just read it, and if there's something you don't understand, you skip it, and because eventually it will show up, and eventually you'll get it, and don't take anything personally. So that's all you need. Your 12 years of computer science PhD can be summarized in those 4 lines. Just go read the documentation. So that is a modern world. You can learn everything from the internet. And Jake, you know how easily you have been catching up just from the documentation too. So coming back to RAG, like I said, if you go to this particular page, which I have, marked on the top of that, great. That session 6 IPython notebook. I have put the link there. This notebook, where did that go? Okay. Apparently not. What is this? Old. Please tell me not closing useful things. Yeah, at the top of this document, I have this Jupyter notebook. I put the kind of the pages from which I'm teaching today. Now, if you're very curious, like there are a lot of different kinds of retrieval itself. Like it's a huge subject in itself, how to retrieve the data the best way. Because remember, I just said retrieve, but there might be so many different techniques, of which one of them is this what we're looking at today. I think it's called dense-X. But there are so many ways, especially if you have what we call structured databases. So most of our data is unstructured in the sense, we go out to the public, we do a bunch of questionnaire, and they just fill the questionnaire. in a way that is, let's say, kind of structured. But if you move it to like a SQL database, it is much more easier. But the sad reality is 99% of the data on the internet is unstructured, which is things just flowing data like this, right? Doesn't have any tags, doesn't know it is like that. It doesn't say anywhere, any metadata that this is the introduction paragraph and this is a definition paragraph, etc. So in an unstructured way. So that is why people make their entire living from just coming up with nice ways to retrieve uh, meaning and knowledge from unstructured data. So let's see now RAG. So you can read on this eventually. So I'll just highlight a few things. What is RAG? Technique for augmenting LLM knowledge. What else? Yeah, LLM can reason about a wide range of topics, but the knowledge is limited to the public data. And this is what I was saying. If you want to create a chatbot on your private data, which plus you don't even want that to be showing up on the internet, in that case is when you specifically use RAG. And RAG has a few concepts. Like on first thing it does is indexing, which is, let's say you bring me 50,000 research papers, and indexing means it kind of ingests the data and creates a nice index from it. Going back to the same picture, like this specific knowledge base is in where we store the data. And the one we use particularly in RAG is called ChromaDB. And one more called VV8, but ChromaDB is, I don't want to get into the details of how it works. It's what we call a vector databases. All right, there you go. Vector database. How do I explain this? It's more like, yeah, instead of language in words, we move it to a land of vectors. So every document in the world gets a corresponding vector. And then the incoming query is matched with that vector instead of matching the incoming query word by word with every single word in every single document. So this is more a faster retrieval. And the reason why we ended up there is this one was talking, I think we were installing this thing, LangChain was ChromaDB we were installing, and that's why I wanted to show you this. And this is an adapter for OpenAI systems. Okay, so where are we now? I think RAG, concepts, indexing. So the whole, like I said, there are two major concepts, index, and second part is retrieval and generation. So the retrieval is literally this guy, the guy who is sitting there, the smart guy. He retrieves the top 10 relevant documents, packs it in a nice prompt and a question, and gives the LLM only these 10 documents, and which of course is within the limit of the token limit of the LLM. And along with the question, hey, given this document, exactly like I had done in that example I had shown in session 4, if I can, I lost it. But it's called the RAG prompting, where we had passed it inside the prompt itself. But this time it is just retrieving these few documents. So let's start getting our hands dirty. So what did we do? We install all this. Okay, we did pip install LangChain community, etc. Okay, so this is the next part where you have to get a unique ID from what we call the open AI key, the key from everything as you might have encountered key before. So anything you want to do on the internet right now, we need to get a unique key. So if you execute this, it's going to ask me what is your LangChain API key, which I think you can go here. I'll paste this also in the I think you might, if you have already created an account in I'll just paste that here. That's where you can find your API key if you already have an account on LangChain. So I think first time you use LangChain, it'll probably ask you to like sign up or something. Yeah, you'll have to sign up, and once you sign up, it'll take you to this Langsmith page, which is pretty much where you can find your key. So I'm going to copy my key and I'm going to paste that back in the place where it was asking me the key. Okay, paste, enter. All right, it's happy with the key. Nope, don't say the key. Are you guys using GitHub also for your programming?
No.
No, not
I
really.
I would recommend it is a very good habit to use GitHub because sooner you yourself will run into these problems that I don't know how you create new file. I used to do latest, then I call it latest underscore the latest, and then it'll be latest. Sooner or later, it becomes a huge mess when you have more and more files you're creating. So this is called version management. And once you start using GitHub, I will just say, just go to github.com and just play around. There are very nice tutorials on even in the GitHub itself and in YouTube on how to use GitHub very well. I think UA Data Lab also has a bunch of open, I forgot the name, open science kind of classes teaching how to use GitHub. And it's very important. It might look very simple right now. So let's see, UA Data Science, UA Data Skill. Education overview, maybe. Data lines, education workshops. It's called, I think it's called Data Science Fellows. So this is one of the basic ones where they teach you like, hey, so this is called FOSS, Open Science Skills, which where they teach you GitHub and all that. Very helpful. And as you know, this department is created for common man, like non-computer science people. And even better, you get money if you attend this. They pay you $3,500 stipend. So do try to attend it next semester. But of course, I'm digressing as usual. So coming back to what we are doing, so we always use GitHub, even though this might it looks easier to create a code in Jupyter Notebook and just copy paste and run it. Soon you'll run into version issues. All right, same thing with OpenAI when I have to call anything related to OpenAI. So this command essentially says, hey, here is my LangChain adapter for OpenAI. Can you connect it to the latest LLM model called GPT-4 or Mini? I could have probably connected to Verde. So here it's asking me for my AI password for OpenAI. Oh, the reason I asked about GitHub is once you get to GitHub and you will find out that if you accidentally, copy your OpenAI personal key and upload it to GitHub, it'll just block you or it'll just give you a ton of error messages because it's a very bad thing to publicly upload your AI keys like this apparently, and I found that out today the hard way. So I'm just telling you guys what I know. All right, so what are we doing this here? So BS4 is it's called Beautiful Soup 4. The idea in this example particularly, what they're trying to do is they're asking the machine to go to this website. It's some blog on LLM powered autonomous agents. And we are going to ask questions only based on this particular documentation. So that is what we are telling the machine. Hey, I'm going to give you a particular web URL, and you have to go parse the URL, or in other words, understand only the actual data and not the HTML content behind it. And which is why for which we use BS4, it's called Beautiful Soup. It's been existing for almost a decade or two now, and it is one of the oldest Python libraries which can pull out data out of HTML file. Not sure if you've seen an HTML file or the actual web page. It's a huge mess where even to get to that one line, the Dormouse story, you have to parse through HTML head, title, etc., etc. So which is why BS4 or Beautiful Soup, I think the version is 4 now, does all that for you. All you have to do is point it to the corresponding web page and it will download the page for you. So this is I'm literally copy pasting, so I'm not doing anything smart here. So it's asking I asked it like, hey, so how many tokens are there in the first page? And it said there's 43,000 tokens or words. And I'm going to ask it like, okay, print me the first 1,000 words, right? So it just goes back. So remember, we are scraping the website, which has a lot of these LLM powered agents. So we finally get the plain text out of it. And that is kind of the bane of current natural language processing, that every data on the internet is not in a friendly text format, but it is wrapped around something. And that something could be HTML, XML, PDF, and PDF itself is a different mess. So parsing is very important. But you as a researcher, you might have your own plain text data, so not to worry about it. Okay, so we already asked Beautiful Soup to like download the data page. The next thing here is a bunch of standard natural language processing techniques. We call it chunking. And the idea is we don't want to pass the whole text together to the database, but we want it to like split it at some meaningful point. So normally we would pass this whole, 10,000 sentences or tokens, words or tokens. But instead, what we try to do is we'll see, like, can we split it? Let's see how a split looks like. So if you try printing the first split, okay, it's a decent split. It says, okay, starts with author, and the agent can do self-criticism and self-reflection over past actions, thereby improving quality of final results. So let's see, quality of, there you go. So it kind of said, okay, hey, everything from top to here is one chunk. So it's more like a division of knowledge and making it nice and clean for the database. Okay, so the next thing what we do here is, this is the database I was telling you about called Chroma. And Chroma lives in this world of embeddings. And I'll quickly give a primer on what an embedding is. So I think I already showed you what an embedding is. So 10 years ago, when people were like, when natural language processing was struggling with trying to make sense out of English language or any language, a bunch of scientists realized that instead, if you create a vector of every word and the frequency of words around it, they found out that the distance between king and queen, the angle, was same between man and woman. So that is how they came up with this idea called embedding, which is nothing but a vector. Like every word in English or the text you provide has a corresponding vector, which looks like this. So it will be like, let's say, for bunny, I mean, it's a bad example, but imagine this way, like bunny is characterized by few characteristics, which is it's alive. So alive gets 0.9 weightage. It's a mammal, okay, 0.7. Is it a bipedal? Yeah, okay, not so much. Is it a gender? Bunny, the word itself is not a gender. It doesn't signify. Is it plural? Nope. Negative is usually like not plural. And bunny doesn't always stand on two legs. So it's not. So the whole idea is we take the inherent meaning of every given word and try to represent that in a form of numbers. Anyway, why am I saying all that? The reason I'm saying all that is that is exactly what I meant by this whole idea of dense retrieval. That is, if you see here, once you, this step here is indexing it using embedding. So we don't work at the word level anymore. What we store in Chroma is vector after vector after vector, which is why Chroma is very efficient, and it's called a vector database. And the next step you do is the retrieval part. And the retrieval part is where we have been seeing this thing, and I've been boring you guys with the same picture since beginning. This part, right? Give me the relevant document. Give me the top 10 relevant documents, top N, whatever. I think at some point you can specify. There you go. You can specify top 6 documents here. And now those will be the only documents I'm going to send it to my LLM, right? So the way we create that is, so let's see. So far the splits are done. And we are creating a vector database, and now the vector database has all the splits, all the chunks, and it internally converts it into vectors. And then once we have the vectors, it's as simple as asking this question, hey, retriever, right? We create the retriever from inside. This is all boilerplate, which is why I'm not even getting into details of it. I would rather you install this and start working on your own research. That way I can teach you how to fish. So you can go read on this, right? So you can go read ChromaDB documentation and find out, okay, what is the meaning of search type? It's probably using some particular technique called similarity. And what is search args? It will tell you most likely it is the number of documents you want. So let me call it top 20 documents, right? So now the length of the retrieve top 20 documents is 20. So let's see what the first document looks like. Okay, the first document, so the question I'm asking is, what are the approaches to task decomposition? And this first document is a chunk which starts at index 2192 and says tree of thoughts, extends chain of thought by exploring blah, 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 and task decomposition comes there. So when we provide 20 such very focused documents to the LLM, we are kind of making it just completely focus on one idea itself. Now, everything I showed so far is only the DPR or the information retrieval part. It's not RAG yet. RAG is this whole system, which is retrieval-augmented generation. We have only done retrieval. We haven't done the augmentation or generation, which is, of course, the job of the LLM, for which we use yet another bunch of boilerplate code. So in LangChain, there is this idea called hub. When you start reading LangChain documentation, you'll understand where as everything to the LLM has to be provided as a question, right? So here, this is like a boilerplate skeleton where they say, hey, here's a dumb filler question. Here's an instance of it. Let me create an instance of a filler question. And this is what we had seen earlier in the prompts, like you are an assistant for question answering tasks. Use the following pieces of retrieved context to answer the question. Right now, we are making the machine focus on only these pieces of retrieved context. If you don't know the answer, just say you don't know. And this is kind of important these days to prevent hallucination. And we can tell it anything we want. Use 3 sentences, do this, do that, etc., etc. And we are going to provide the data in a second. Right? So let's see. This is a message. This is a content. And the next step is, like I told you, putting it all together, right? So now on one side, we had all these documents which we had retrieved from our retriever, right? The retriever and the documents are sitting there. And which is why Lang is called a chain, because they chain things using this pipe. The chain is a nice way of saying they combine this. First, they provide the retriever and the docs, the documents which we had retrieved in the previous step, which is retrieve_docs here. So using that docs, combine that with the prompt. Here is the name of my LLM, which I think we might have specified somewhere. There you go, up here. That's it, LLM. I don't know, you can find out. But long story short, you're done, right? So now you're asking the same question, what is task decomposition? And asking the machine that question. And it gives a more inferential answer. So you might ask, what is the difference between this particular passage and the answer it gave here? So everything before ChatGPT was this, which is purely information retrieval, which is, hey, give me a bunch of relevant documents. But this is probably a bad example. Usually LLMs are much more powerful in what we call inferencing, which you might have experienced in your own experiments with ChatGPT, that it can connect a bunch of things and give you answer in a nice, understandable way. Anyway, my point is LLMs are more powerful than retrieval methodologies. Now, interestingly, remember we had told the LLM to, where is my, like, do not answer outside. There you go. So we said, if you don't know the answer, just say that you don't know. And I want to check that because what we have provided, it is a bunch of technical documents. Who is the next president of the United States? Okay, so let's see how this responds. I don't know. Perfect. Okay, this is exactly what we wanted it to do, because if it was relying from its previous knowledge, where there's some bias, let's see. Aha, it's tempted to pick it from the other document. So now let's particularly say answer only from the documents provided. I don't know if it's going to listen to it. It's like a see, I mean, LLMs are like a stubborn newborn child. It's given to you, and you have to like figure out what it is capable of. I personally don't agree with that methodology, but that's my school of thought. Yeah, so that's all I had to show. I wanted to show you guys today. So we now have a methodology to like take any URL you want and just send it as a bunch of retrieved relevant documents and just pass it on to the LLM. So instead of like OpenAI, you can probably plug in like, so this you might have like I said, you had to pay for OpenAI, but instead you can figure out like how to do it with Worday or any of the things we have shown you before. And I'm expecting one question right about now. Do you have any questions about it? About what we saw so far? Whatever I have showed you, do you think it is helpful to run a RAG over your data that you have currently?
Just kind of getting started, so I'm not sure.
Yeah, no,
So
no issues.
I'll
Like I
I'll give
said,
you the I don't know answer.
no issues. Now, usually the data as a researcher is like, like Jake has is probably a bunch of, I don't know, research papers and documents. But remember, we
Mhm.
are asking this guy to scrape it from a website. We are not giving it a bunch of text files. The point is, sure, of course, these things you can provide any type of data. And it gets messier depending on the form of data. If you have a .txt file, you are the most blessed person on earth, which is very rare. But now if you have a PDF file, it gets slightly more trickier. And all of them are here. All of how do you like do parsing with PDF and all that is probably you can just, go search for it. So long story short, my goal here was to like, I show you one example of how RAG is done. Now you can just go read on like, it might be as simple as a Google search. Let's see. Uh, how to use LangChain to index PDF, let's say research papers, right? So you get like a bunch of examples, videos, or whatever you want. All right, there you go. So how to load PDF. So it's all there. Like I said, my only goal was to show you what is where. Yeah, the how-to guides is usually like a very helpful place. And once you start reading, things will start making familiarity. Don't get too lost in like the LangChain expression language and all that, which is why I wanted to introduce like a very high level EULSA introduction of how LangChain works. And now all you have to do is, hey, you kind of have the rough idea. Let's use it for X. And what X is completely up to you. There is always an answer, like depending on how to load a PDF, how to load a text file, index CSV files, or whatever you want to call it, right? In a Chrome. Somebody would have done like there you go. It's literally a chain. Somebody has created a chain for CSV. So that's all I have for today. I hope I have given you like some pointers where you can start playing around with this and get your hands dirty. Uh, yeah, and like I said, there's unstructured, and you can have any type of providers, Hugging Face, Microsoft, OpenAI, or Worday for that matter. Questions? We have 4 more minutes technically. And all this is already up in the AI Maker Space session 6.
Yeah, I think
Uh,
I'll go play and see what I can get to work.
Perfect. That's the best attitude in research. Like just go break things and see what you can, it's worst case, you're going to get an error message. You're not going to blow things up. So
You
feel
know,
free to.
do you know places like, is there any office hours on campus where people can just sort of go physically with their laptop and sit there and show them to and say, this isn't working, help me make it work?
Yep. There are a couple of things. Let me show you that. Yeah. So we ourselves have a bunch of those had, at least. Let me see if they still have it. What was it called? Okay. There is Res Bazaar, if I remember correctly, Bazaar. Tucson, Research Bazaar. It's like it's kind of the same idea. It's even like a meetup group where people bring in the same idea of like bring a problem. Our lab used to have this thing, coding, coding time. I forgot. Let me dig it up and find out if it's still there. There's even called women in computer science. So my point is, all of them have meetings like. I think Monday and Wednesday, 8 a.m. is when the data lab, we have a bunch of people sitting there, like waiting for you to show up with questions. Something like that. Each one of these groups have their own office hours. Let me dig up and find those details. It's mostly somewhere here in the data science website. I have to just go dig on it, which you might as well do. But yes, the short answer, yes, we have a lot of these things, or even like drop an email to Data Lab, somebody will reply. Might eventually, like they will contact you of a Data Lab to learn how we can partner. I think here's a mail ID, and they will point you to some. Oh, there you go. Coffee and Code, Hacky Hour, Data and Wiz drop in Code Commons. This is the ones we have. These are the names I was looking for. Coffee
Okay.
and Code is it's going to Research Bazaar. Cool. Hacky Hour is, I don't know, everything is going to Research Bazaar. But either way, this exists, just Google these names. And okay, so yeah, we are all part of it. So apparently, I'm part of it. Okay,
Yeah,
so there you go. All the data is there. So just show up and people are there already helping each other.
cool. Thank
Okay,
you.
great.
All right, guys, thank you. Hope you learned something new and hope it's going to help you in
Yeah,
your
this was
work.
very helpful. Thank you.
Okay, yeah, thank you very much. Yeah.
Bye. Bye.